So there are three ways to handle a one-to-one relationship. When we move to one-to-n relationships, there are only two ways, but these are variations on the same themes that we saw in how to map a one-to-one. The first approach is the foreign key approach, and that is to take the foreign key from one entity type and place it in the other. However, unlike the one-to-one, in this case, the direction is determined. You need to take the key from the table of the one and put it in the table of the many. So what we would do here is we would grab a department ID and put that key in the employee table. This is the employee works for a department. So an employee works for one department, and a department has working for it many employees. So when I say the table of the one, I'm referring to department because that's where the cardinality of one is. And to link these two, the easiest way, and in fact the most common way, is to take the key from the one and put it in the table of the many. It's also interesting to note how partial and total participation will affect your database design. Note here that we have a partial participation between the employee and the works for relationship. This means that not every employee works for a department. Perhaps there's the CEO of the company and the CEO has no department. So when you have partial participation, we already know that we're going to take the key of the one and put it in the table of the many. When we put department ID in the employee table, it will be a foreign key. That much we already know. But looking at the partial participation, we say to ourselves, when I bring department ID into the employee table, I have to allow it to be null, because at least one employee might not have a department, so it cannot be not null. However, if we had a double line here indicating total participation, then when we bring the department ID into the employee table, we would make it not null to enforce this total participation between employee and the works for relationship. The second way to model a one-to-n relationship is to again build a bridging table. This is known as the cross-reference or relationship option, and it's a three-table option. In this case, we would have the employee table, we would have the department table, and we would have a bridging table that has the employee ID and matching it up with the department ID. Now, we know that once we do this, our efficiency is going to go down, because now to get employee and department information, I have to go to 3 tables instead of 2. So you may ask yourself, why would I ever want to choose this option? And this option is not the most common way to solve a one-to-n. But there are 2 reasons why we would want to do this. The first one is to hedge your bets. If you think this n-to-1 relationship in the future might move to a many-to-many relationship, then having the bridging table preserves your database structure. For example, let's say that you expect to hire some employees that will work part-time in one department and part-time in a different department. And while you don't have them now, right now you have the n-to-1. An employee works in only one department. If you wanted to allow for that future case where the n-to-1 is going to turn into a many-to-many. So one day, for example, this could not be a 1, and maybe this becomes many. If that were to happen, then you would need the bridging table. So some database designers will build the bridging table in to a one-to-n relationship just a plan for the future in case the relationship cardinality changes. There is a second reason why you might want to have a bridging table for a one-to-N relationship. Let's switch up our example a bit and talk about military personnel. You may have military personnel who are awarded the once-in-a-lifetime Medal of Honor. And over the years, we give out many Medals of Honor. And the Medal of Honor will keep track of their medal ID, the date it was awarded, and the rationale for why a military personnel would receive such a prestigious honor. Now, we said before that you could take the key of the one, which would be medal ID, and put it into the table of the many. And that was the previous way we modeled. However, think of all the military personnel. That's quite a large number. And think of the tiny amount that actually are lucky enough to receive a Medal of Honor. So while this would work, we would have a Medal of Honor field, the medal ID foreign key, in this table, and it would be very sparsely populated. Maybe less than 0.1% of military personnel will ever receive this medal. So we'll have a foreign key column that will have an awful lot of nulls. And so maybe that's not the best way to do it. Maybe the best way to do it would then be to just build that bridging table. And for the relatively few military personnel that get awarded the Medal of Honor, we'll record their SSN and we'll record the medal ID. And we'll do that in a bridging table because we don't expect there to be very many records like that. On to step 5. Step 5 will tell us how to map the final type of relationship, the many-to-many. And I've got good news. Step 5 is the easiest one. There's only one choice. Whenever you have a many-to-many relationship, you must build that bridging table that will keep the primary key of the two entity types that it bridges. So here we have our very familiar movies and actors. A movie can have acting in it, many actors, and an actor can act in many movies. Many-to-many relationship, we need a bridging table. That bridging table could be called acts. It could be called the cast. You can come up with any name for it you like. But you will need to have a bridging table for many-to-many. Don't forget that when you build bridging tables, you also need to build in the attributes of the relationship. So the role that an actor had in the movie and the salary that the actor made for the movie would also go into the bridging table. Step 6 is a very easy step. It's the mapping of multi-valued attributes. Here we see an example of a department that has a name, a number, and multiple locations. The reason that locations is a multi-valued attribute and not its own entity type is that we simply want to record the location name. To model this in the physical database, we obviously make the department table, and then we pick one of the primary key candidates that are underlined to be the primary key. So in this case, we will pick the number. So we will use this guy as our primary key. And then, like any other strong entity type, we will put the name in the table as well. But the multi-valued attribute locations is not simple. What we need to do now is to make another table called location. And when we make the location table, we have to grab the primary key of the department, like 11 for the HR department, or 15 for the IT department, and then just put the location name next to it. So a very simple table, the location table. The location table is going to have a composite primary key. So it's going to take both fields, the department number and the name, to uniquely identify a row. But this is the easiest and simplest way to handle a multi-valued attribute.